Hello, my name is Jeremy Kim, and I'll be talking about the DRAM latency PUF. A PUF is a function that generates a signature that is unique to a given device. PUFs are often used in a challenge response protocol, where a trusted server issues a set of input parameters to a device, and the device generates the PUF response depending on the input parameters. The trusted server then receives the PUF response and can authenticate the device. In this work, we show results from a detailed experimental characterization of 223 state-of-the-art LPDDR4 DRAM devices. We characterize DRAM latency by observing the effects of accessing DRAM with DRAM timing parameters reduced below manufacturer recommended values. We make two key observations. First, a cell's probability to fail when accessed with a reduced timing parameter is directly correlated with random variations that arise from process manufacturing. Secondly, we note that these error patterns from inducing DRAM latency errors are unique to a device and highly repeatable. Here is a cartoon showing the manufacturing variation across a region of DRAM. When accessed with a reduced timing parameter, some cells have a high percentage chance of failing, while others have a low percentage chance of failing. A DRAM cell holds its charge in a capacitor and gets read out by the sense amplifier via the bit line. Initially, the bit line is kept at VDD/2. When the word line is driven high or activated, the capacitor begins to share charge with the bit line. The sense amplifier is then enabled, and the voltage differential on the bit line is amplified to an I/O readable value. In order to ensure correctness of operation, the memory controller can only read data TRCD time after the activation. We could read this data earlier when it reaches a readable voltage threshold, but other cells that are weaker due to process variation might fail. Our method of inducing TRC latency errors is to reduce TRC below manufacturer recommended values. Cells that are read when their bit line's voltage is lower than the threshold have a probability of failure. This probability increases as you read further below the voltage threshold. The DRAM latency PUF generates a PUF response by inducing latency errors in a region of DRAM. We find that the error patterns from the latency errors in a DRAM region satisfy the requirements for an effective PUF quite well. The DRAM latency PUF can generate a PUF response in 88.2 milliseconds. We show by direct comparison that this is orders of magnitude faster than the previous best DRAM PUF. Please come to my talk at HPCA 2018 if you would like to learn more or have any questions. Thank you very much.